All right, here is the video guide for lesson 2.2.2, area of triangles and composite shapes. We're going to work through the lesson. Composite shapes are going to be the first ones we look at, and it's just going to be shapes such as this, where it is kind of two shapes combined into one shape and how we can find the area of that. And then we're going to work into finding the area of triangles and creating a formula for the area of triangles. And when we get that formula, maybe it's something you'll remember, but we're going to kind of see why it's that case here in this lesson here today. Okay, so the first one here, when we're looking for area of a composite shape, what we need to do is break it into shapes that we know how to take the area of. And so for me, I draw a line here, and there's different lines you can draw to break this shape up, but I'm going to draw the line right here. And I now have two rectangles, okay? I have a length of 5. But now I need to figure out, well, what is my length up here? Well, if this is 8 and the whole thing down here is 11, well, that means this up here must be 3. So I have 5 and 3 there. I have 8 and 3 here. And so just to show you the first one, I won't do all of them here, but 5 times 3 is how I find the area in this one, because our area of a rectangle is length times width. So 5 times 3 gives me 15 in here. My length of this rectangle is 8 and 3, and that gives me 24. 8 times 3, length times width. So then to figure out my answer of what's my total area, I have to do 15 plus 24 equals my area, which in this case would be 39. And that would be feet squared, because that one tick here, 8, that little marking is feet, so that's 39 feet squared. Okay, and that's what we're going to do here in this problem as well. Okay, we want to find the area of the shaded region. Well, let's find the area of the whole thing, and then let's subtract out the unshaded region. Again, these are rectangles, so we're going to use length times width. I won't do this one though, and then we're going to take a look at here. We have this square, and it's a square, which is the same thing as a rectangle practically, except for 4 equal sides. So we do length times width again for the area, but we have these algebraic equations. And so what we need to do, and I'm going to bring up a thing so I can work on it here, is we have to take the one side times the other side. So 2x plus 3 being multiplied by x plus 4. Okay, now in the math notes section, if you go to the ebook, it shows us this method, and I'm going to show it to you here too. We have to use the box method, is what I like to call it. We create a box, and on this side we put a positive 2x and a positive 3, and on top we put a positive x and a positive 4, coming from 2x and 3 and x plus 4. Then we multiply into each box. So 2x times x gives me 2x squared. 2x times 4 gives me 8x. X times 3 gives me 3x, and 3 times 4 gives me 12. And then what I can do is combine these two boxes here. And so my final answer here, once I do it, is 2x plus 11x plus 12, because that 3x and that 8x combined to be that 11x. And that would be my area of this shape right here. Okay? Again, that's in the math notes box as well in the ebook if you want to see that method a little bit further. Last one here. Again, you can break this shape up in different ways. I'm going to draw my lines right here so I can see that I have 3 rectangles here. Okay? I can find out what these distances are because they're 3 equal sides that must add up to 27. So 3 equal parts that all add up to be 27. You can figure out what these distances are. Similarly, you can figure out what these distances are because they're 3 equal sides that add up to 18. Then once you have these lengths here, you can find the distance, you can find the area of each of these 3 rectangles. And I'm going to leave this one for you because it's the most challenging of the composite shapes that we do today. And I want to see how you go after it and how what answers you get. Okay, now here we get into triangles, okay? And it's the beginning of developing our formula for triangles. And what we see here is that if we do 5 times 14, if we do our length times our width, okay, we end up getting the area of this complete rectangle. But the thing is our shaded region, our triangle here, is only half of our rectangle. So if we want to find the area of this shaded region, this triangle, we can do the length times width, but we're going to have to multiply it by 1/2, or we'd have to divide it by 2, same thing, to figure out the area of that shaded region. Okay, so you have this length times width from finding the whole shape, but then you want to multiply it by 1/2. And we're going to see that going on, I think, later on here. Okay, so now if I look at this, I have two right triangles, just like I had here. The shaded region was a right triangle. And so I can try to use that same method here. I can do this right triangle, doing, it's going to create a rectangle, so let's do the length times the width, and then, multiply it by 1/2, see what I get for this right side. And I can do the length times the width multiplied by 1/2 and see what I get for the left side as well. And then it's just a composite shape, so we can find the area of this side, find the area of this side, and then add those two areas together. That leads into this problem really nicely, though, where it says, well, what about this? This was 5 times 14 divided by 1/2, and hopefully when you calculate this area, you see either the exact same area or something similar to it. And then he asks, well, did I need to calculate it because they were the same area? Why were they the same area? And he's like, do all triangles that have same bases and same heights have the same area? And we get this nice little handy e-tool to investigate that. We can change the height, we can change the base, and you can see there's an area down here. And if you start skewing this triangle so that, the height is out here, or the height's inside, or the height's over here, we should hopefully see, as long as the height and the base stay consistent here, we should see our area remain the same. And so we get to play with that, and we get to write out our ideas and draw out our ideas here and say, like, well, I think that's the case for triangles. As long as the base and the height remain the same, it doesn't matter what the triangle looks like. We can use that 1/2 times the length times the width, or what they call the 1/2 times the base times the height. Okay, same thing as I was just talking about, but they switch it to base and height because when we look at a triangle, we have a given height and a given base. Okay, now we want us to know why is that? Why is this the case? Well, every triangle is either half of a parallelogram, either half of a square, or half of a rectangle. Okay, and our equation for the area of a rectangle, for a parallelogram, for a square is base times height, and these are just, every triangle is just half of that. And so we can explain that and we can draw that out here. Okay, now we get to try our method out here. Okay, we got to choose a base, choose a height, and then calculate what that area is using our formula 1/2 base times height. Now, this one's pretty obvious what the base and the height is, but we get onto the next one. Which one's the base, which one's the height? Okay, and then how can you, to yourself, make sense of, okay, that's going to be my base, that's going to be my height? Okay, as we go on to this one too, we can see, like, okay, what's my base, what's my height? Don't forget about this. Look at how the base is represented here. As I start changing the base here, look, it's still, well, let's look at it like 7.7. As I start skewing it, you can see that even when my line's out here, it's still 7.7. So we're not really including this outside part as our base. So remember that as you're working on this problem. Okay? Then go back, and it's going to ask us to actually start investigating, why did you choose these as your base and your height? So it goes back to this problem here. It says you probably chose 6.8 and 5.9, but why did you choose that? Okay, and that's what we're looking for when you write in here, because it's going to help make sense to you, or try to, solidify those ideas to you, why we're choosing the base and the height like we do. Okay, last one, kind of a challenge problem here. Is that they are arguing which one on here is the height of the triangle. Okay, is it Mario's height, is it Raquel's height, or is it Jocelyn's height? Which one is the correct way to represent the height of this triangle? And again, don't forget about your e-tool here. It represents this problem pretty well. It can help you out. Okay, and then the last one here, just a learning log. Please don't forget about it. Write out the way that you found those areas today. Write out some, maybe the formulas or the methods of what you did today. And if you had any questions through any of these problems, some of them get a little challenging, I'm happy to make an individual video for a specific problem.